or H2, or molecular hydrogen. This is a critical nutrient for many different systems in our body, but in particular, it does play a role in the electron transport chain and ultimately through producing cellular energy. What I want to do first is I want to go over the electron transport chain steps so that you could first understand what are the steps to energy production, and therefore we'll start to understand where hydrogen is important and what role we can use for hydrogen to help improve ATP production. The electron transport chain is literally that last few steps of energy production in our cells. And picture it as a factory. As a factory, you need to deliver raw materials, and then you need to process those raw materials in order to make a product. And in this case, the product is ATP, which is the currency of cellular energy. It's what cells need to do all the different jobs that cells are required to do. And so we have in the electron transport chain, we have to get electrons from one end of the factory as a raw material through each step of the way until we get to the last step, which is ultimately energy production. There are a few spots in the electron transport chain that are considered to be stationary. And then you have a few spots in the electron transport chain which are considered mobile. And the mobile carriers are responsible for picking up electrons from one complex and delivering it to the next. And it just repeats that cycle. So you're trying to get electrons down this chain, and a few of these are stationary. You can't get electrons from one complex to the next magically. You need a delivery system to do that. So mobile carriers are just that. They go back to one complex and deliver, and all they do is repeat that. And as long as we can move electrons down that chain, we can get the electrons to the last step and ultimately create energy as a result. They have long names. We're not going to get into their long scientific names in this moment. So we'll just call them complex 1, complex 2, complex 3, complex 4. And ultimately, two mobile carriers. One is called ubiquinol and the other one is called cytochrome C. And then at the end stage, you have this thing called ATP synthase, which is literally the machinery in charge of making ATP. So as you see, now we're talking about literally the very last step of the electron transport chain and all the other modalities from our diet, glucose, fatty acids, NAD drips, or NAD precursors, or even methylene blue. These are all different high energy molecules that donate electrons to the beginning raw material phase of the electron transport chain. The electron transport chain is a concentration gradient, meaning it has to start with a high concentration, and every step it loses some energy density, but there's got to be enough for it to flow from high energy down to low energy, ultimately until it gets to oxygen being that final electron acceptor. We needed CoQ10 to be a mobile carrier. We needed red light to stimulate cytochrome C. We needed oxygen as that final acceptor. These were all the steps. And literally every time we made a step from one complex to the next complex, what we didn't really talk about was each step of that way is releasing hydrogen into the intracellular membrane. And the reason we're doing that is to create another gradient, a hydrogen gradient. So as we're moving electrons from one step to the next, we're also releasing hydrogen into that space. And as we release hydrogen into that space, and we get this high concentration of hydrogen, it wants to also move down its concentration gradient. So we have this high hydrogen environment, and it's looking for an avenue or a way to move through that membrane. ATP synthase, which is the enzyme responsible for ATP production, is a pore or an opening in the membrane that allows hydrogen to move down its concentration gradient from high concentration to low concentration. So number one, as we imbibe increased levels of hydrogen, again, it will play multiple roles in our body, especially in the redox reactions throughout the entire electron transport chain or through all of the rest of cellular metabolism. Hydrogen is a necessary ingredient for all of these redox reactions, but it's also critical for that high hydrogen concentration gradient in the intramembrane space to allow to drive ATP synthase. And so as we either drink or inhale hydrogen or molecular hydrogen or hydrogen gas into our system, this is one of the locations that that gas can go, again, driving increased ATP production. As we get that concentration gradient and it's moving down through ATP synthase, there's machinery in that pore in ATP synthase that's literally going to bind two molecules together, ADP, with one extra phosphate, right? So diphosphate, DP, to triphosphate, TP. That's what ADP and ATP are. And so as we bind one more phosphate group to ADP and make that final ATP, that's the energy that we're looking for, and it is hydrogen driving that entire process. So that is the final step in the electron transport chain where the actual ATP molecule is being made. And that's the role that hydrogen plays in that process. So here's a few questions about hydrogen that I also get. When should I take it? How much can I take? Can I take too much? So one of the reasons I really like hydrogen, it's a reducing agent. What does that mean? Ultimately, it's like an antioxidant. It's not actually an antioxidant, but it behaves similarly to an antioxidant. In other words, oxidation acts often as a free radical. So when we get oxidized, it breaks down cell components. It could break down a cell membrane. It could break down DNA or nuclear membranes. It could break down the mitochondria or the mitochondrial membrane. So oxidation has been known to do damage to a lot of cell parts. At the same time, antioxidants protect us from that oxidation. We've done multiple videos on how much oxidation is okay, how many antioxidants, when should we place antioxidants into our system with regard to, let's say, hyperbaric therapy. So take a look at some of those videos. But one of the reasons I love hydrogen is because it does behave similar to an antioxidant. The opposite of oxidation is reduction. So hydrogen is a reducing agent. But one of the great things about using hydrogen is you really can't get so much that you would become over antioxidized. In other words, other antioxidants that we use, selenium, glutathione, vitamin C, to some degree, you can definitely get too much of. Instead of over-oxidized, you could become over-reduced. And there's consequences to that too, because some oxidation is absolutely necessary for cell signaling of repair and regeneration and healing. So we don't want to lose the value of that. At the same time, we don't want to go too far either direction. So that entire process of oxidation and reduction is called redox. Reduction, oxidation, redox. Hydrogen is a reducing agent, but it is not capable of creating an over-reduced state. And so we can take in quite a bit of hydrogen. Hydrogen is also used in so many other places in our body that it's really helpful to have a surplus of hydrogen in our system. And so you can take in quite a bit. We use hydrogen water primarily as our delivery system, or what I recommend to patients. We have a hydrogen water system in our house, and I take a few glasses in every day. Whether it's right near a hyperbaric session or not, in general, I don't think it matters. There are certain times where we are trying to reduce some of the oxidation from hyperbaric for a patient who's very sensitive that way, in which case putting hydrogen water roughly 30 minutes or so before a session could be very helpful. But for most of us, especially if you're not over-oxidized, just making sure you're getting, let's say, a few glasses of hydrogen water in a day is sufficient to make sure you have enough hydrogen gas in your system, enough molecular hydrogen in your system to do all the jobs that hydrogen needs to do. It doesn't necessarily need to be placed specifically before or after other therapies. It just needs to be there regularly.